7.6 Radians and degrees. So, when you're trying to measure a length, you could actually use a variety of units. You could use inches, you could use feet, you could use meters, you could use centimeters, you could use a variety of things. You could use miles, whatever. Also, with temperature, you could use degrees Celsius or degrees Fahrenheit. Well, just like this, we can measure an angle in a different unit. We're used to measuring angles in degrees. However, there's another way to measure angles, and that's in a unit called radians. So what is a radian? A radian is actually the particular measure of a central angle which creates an arc length of exactly one radius, regardless of how big that circle is. So that means in every single circle, no matter what the radius is, the angle that represents 1 radian will take up the same exact proportion of the circle. All right, so let's talk about the angle measurements of a full circle. A full circle is 360 degrees. In radians, it's equivalent to 2 pi. Half of a circle is 180 in degrees, but it will be equivalent to 1 full pi in radians. We can see visually about how much of a circle 1, 2, 3, and so forth radians would take up. You can see in the first picture, 1 radian takes about 1/6 of the circle up. 2 radians is a little bit more than a quarter of a circle. 3 radians is almost a half circle, but you'll see we need a little bit more to create a half circle. And how much is actually going to be exactly the irrational number pi. So then we have 4 radians, which is more than a half. 5 radians is even more. 6 is close to a full circle, sorry. But we need just a little bit more, and that would actually be equivalent to exactly 2 pi all the way around the circle. So these are just visual diagrams of what 1, 2 radians and stuff would look like. Degrees I know is very familiar with you, or you're very familiar with. However, when you get into higher level math, we tend to use radians even more, and actually it's actually easier to use radians in a lot of cases. Okay, so since we're just learning this new unit, we're going to just convert back and forth from radians to degrees and degrees to radians in this particular section. So to convert between degrees and radians, we're actually going to need to do what we do in your science class. And we're going to do a conversion ratio. So first thing we need is a conversion ratio, an equivalent statement between degrees and radians. So I actually gave you 2 equivalent statements between degrees and radians on the front of the page. 360 degrees is equal to 2 pi, or 180 degrees is equal to 1 pi. You can actually use either to convert back and forth here, but I'm going to go ahead and use the 180 over pi, and that's pretty traditional, just because it's obviously, it has smaller numbers. Smaller numbers are always easier to deal with. Okay, so we have 180 degrees divided by pi radians, or you can also think about it as pi radians divided by 180 degrees. Okay, so which one do we use? When you're converting, you always want to take the unit that you're starting with and make sure that that's in the denominator so that it cancels out. And the unit you want should be on the top. So for our very first ratio that I wrote down, we would be converting from radians to degrees. So I'm going to go ahead and write that down, from radians to degrees. Okay. And the second ratio that I gave you would actually be used in a conversion from degrees to radians. All right, so let's go ahead and just convert some of these values. We want to convert 30 degrees to radians in our first problem. So we're starting off with degrees. Okay, as I had mentioned, we want to multiply it by one of these conversion ratios. Since we have degrees, and that's what we want to get rid of, we want to make sure degrees is in our denominator, and we want to gain radians, so radians will be in our numerator. So this would actually be the second ratio, pi radians to 180 degrees. All right, so we're going to multiply by this ratio, and what we'll have left is an answer in just radians. So to do this, I'm going to essentially multiply across. So 30 times the pi would give me 30 pi. And the denominator is 180. At this point, you're going to take the numbers, the 30 over 180, and reduce it as much as possible. Obviously, the zeros would cancel, dividing by 10. And then we have 3 over 18, which would simplify even further by dividing out a 3. You would get 1 over 6, and then the pi stays on top. So essentially what we have is pi over 6, because we typically don't write 1 pi. We typically just write pi. And this answer would be in radians. Now the reason why I know that it is in radians is because if you look over here, the original way we set it up, we had degrees and then degrees in the denominator, so those would actually essentially cancel each other out by dividing by it. And the unit that's left would be our radians. So 30 degrees is equivalent to pi over 6 radians. Okay, let's try another example. Convert 270 degrees to radians. So once again, we're starting with a degrees, and we want to convert to radians. So we need that pi radians over 180 degrees once again, so that our degrees will cancel and we'll be left with radians. So to multiply here, I'm going to multiply the 270 and the pi, which obviously we can't really simplify that further, and we'll be dividing by 180. Now you're going to simplify the 270 over the 180. Again, I see that they're both divisible by 10, so I'm going to go ahead and just cross out the zeros. And I have 27 over 18. Both of those are divisible by 9. 27 divided by 9 gives me 3, and I still have the pi. And 18 divided by 9 would give me 2. So that means that 270 degrees will be equivalent to 3 pi over 2 radians. Okay. Moving on to example 3, we're actually going to convert from radians to degrees this time. So I'm starting with 3 pi over 5 radians. Since I'm trying to get rid of radians, that means that in my conversion ratio, I want to make sure that the radians is in the bottom. And since I'm converting 2 degrees, I need the degrees on top. The conversion ratio, which has the degree on top and the radians on the bottom, would be 180 degrees on top over pi radians. The radians will cancel, leaving my final answer in degrees. Okay, so again, I'm going to multiply across the top and multiply across the bottom. 3 times 180 is actually going to give me 540 on top, and then I also have a pi. On the bottom, 5 times pi would just be 5 pi. You'll notice that the pi's cancel. And then I'm going to divide 540 by 5 to get 108. And then our final answer should be in degrees because that is the only unit left. So what we have is that 3 pi over 5 is equivalent to 108 degrees. All right, last but not least, let's convert pi over 12 to degrees. So we're starting in radians. To get rid of the radians, we want to divide by radians and add a degree symbol in the numerator so that I can gain that unit. This would mean that I'm going to use the conversion ratio of 180 degrees over pi radians. Again, to simplify, I'm going to multiply across the top. So on top I have 180 pi. And then across the bottom I just have 12 pi. The pi's cancel, and I'm left with 180 divided by 12. So if I actually take 180 divided by 12, I get a nice answer of 15. And that would be in the only unit left, and that would be degrees, because those radians would cancel. And there's my final answer. So please note, anytime you want to convert from radians to degrees or degrees to radians, all you need to do is multiply by the appropriate conversion ratio and simplify your answer to convert.